Ever feel like, you've got this like supercomputer in your head, but it can only remember like 3 things at once?
Yeah, that's basically the problem with large language models right now, isn't it? They're amazing with language, but their memory and like computational abilities, not so much.
Exactly. We're talking about things like ChatGPT, right?
Mm.
Systems that can write you like a sonnet or explain quantum physics, but then forget what they just said 2 sentences ago. Huge bottleneck.
For sure. And people have been trying to tackle this, right? Like there's retrieval augmented generation trying to give LLMs access to these massive external databases. Like imagine a superpowered Google search.
Makes sense.
Yeah.
But what are the downsides? I mean, if they have to constantly be looking stuff up, doesn't that slow things down?
Totally. It's clunky. And it still doesn't give them like inherent reasoning abilities. They can find info, but not necessarily understand it deeply or do complex calculations with it.
Okay, so that brings us to today's deep dive. We're diving into a radical new approach. Knowledge implants for LLMs. It's like giving them a specialized brain upgrade.
It is. And the potential is huge. The core idea, which is actually quite elegant, is to directly embed the knowledge and computational stuff within the LLM, not external tools.
So instead of just giving them more info to access, we're upgrading their actual processing power.
You got it. The research proposes these implants would have 2 main functions. First, picture this. A massive organized library of facts, but compressed incredibly efficiently. That's your knowledge storage.
Okay, so it's not just a random jumble of data. It's structured in a way that the LLM can actually use.
Exactly. And that's where the second function kicks in. It's like building a specialized calculator right into the LLM, able to do complex logic calculations, allows it to actually manipulate and reason about the information, not just retrieve it.
That's where things get really interesting. But how do you actually implant something into a neural network? These things aren't physical computers with hard drives you can just swap out.
Right. This is where the real ingenuity comes in. It all hinges on how LLMs process language. They break text down into these smaller units called tokens, which can be words or even parts of words. The researchers propose building a bridge between those tokens and, well, the language of computers, bits, zeros, and ones.
So we're almost like teaching the LLM a new language, one that lets it directly use this implanted knowledge and logic.
Exactly. The paper uses the example of an IPv4 address, like, a 127.0.0.1 quite.
Oh, sure. I've typed that in enough times.
Now imagine each part of that address. Each number is separated by a dot, representing a piece of information. This method is amazingly efficient for encoding complex data in a way the LLM gets.
So it's not about just throwing more data at the problem. It's about making that data inherently meaningful to the LLM.
And crucially, this approach uses something the LLM is already familiar with, those dotted decimal patterns. Makes the integration more seamless.
Okay, I think I'm starting to see how this could work. We're basically giving LLMs a whole new way to think about information, how to interact with it, but how does this actually play out? That's what I'm curious about. So we've given our LLM this incredible upgrade, right? This knowledge implant, this superpowered library and logic processor all in one. What can we actually do with it?
Well, the possibilities are huge, but the research gives this really cool example. Using an LLM with a knowledge implant to navigate a complex video game.
Okay, now I'm intrigued. What game are we talking about?
Super Metroid. It's that game known for its huge map and all those intricate puzzles.
Oh, classic. Yeah, I remember spending hours trying to find my way around that world.
Totally. So imagine you're playing right and you get stuck. You hit a wall. You could ask an AI assistant with one of these knowledge implants for help. And this AI, it'd have access to the entire game map, item locations, enemy weaknesses, the whole knowledge base, basically.
So it's like having a Super Metroid expert on speed dial. That's wild. But how do we keep the AI from just telling the player the solution? That wouldn't be much fun.
Right. It's all about guidance, not just giving away the answers.
Yeah.
And that's where the reasoning capabilities of the implant come in. It can look at the player's location, their inventory. It can even simulate potential actions to give actually helpful advice.
So the AI is running thousands of what-if scenarios in an instant. Okay, if the player goes this way, they'll run into this enemy, but if they go that way.
Exactly. It can strategize, just like a human player would, but with so much more knowledge and processing power behind it. The paper calls this controlled natural language. It's really key to making this whole thing work.
Controlled natural language. I'm not sure I've heard that term before.
Basically, it means using specific symbols or phrases in the text to trigger the implant's functions. So instead of, overloading the LLM with all this complex code, we can use things like, for example, the greater than or less than symbols, or even simple arrows to initiate specific calculations or access certain parts of the knowledge in the implant.
Oh, I see. So it's like a set of secret commands, but they're right there in the natural flow of the language, and they let us tap into the implant's power.
Exactly. And what's brilliant about this is it uses the LLM's existing knowledge. Those symbols already have meaning from the massive data sets they trained on. The integration is surprisingly intuitive.
I like that a lot. We're building on their existing strengths to get these whole new capabilities. This video game example is really cool, but it feels almost a little too specific. What about the bigger picture?
Oh, this is just scratching the surface. This tech could completely change so many fields, not just gaming.
Yeah, that's what I want to get into. This whole thing with knowledge implants for LLMs, it feels almost like a totally new way of thinking about AI, doesn't it?
It really does. I mean, it could be huge. And it's not even just about making AI smarter, which is obviously a big part of it, but making it more, trustworthy.
Right. It's something I hear a lot of people worried about, like this whole black box thing with AI, right? We don't always get why they make the decisions they do.
Exactly. But with a knowledge implant, because we've got that info, those reasoning processes, all like tightly woven in there, structured, we have a way better shot at understanding how it gets to a conclusion. We can actually audit its reasoning.
So instead of having to just trust the output, it's like we can look under the hood and actually see how it's working.
Perfect analogy. And that kind of transparency, it's really important, especially if we're going to start relying on AI for even bigger, more critical stuff.
Which brings us to the really cool part. What can we actually do with this? What are the big, exciting applications?
Oh, man, the possibilities are huge. Like, take healthcare. Imagine an AI that can look at a massive medical database, patient history, research, everything, and then give doctors these really detailed diagnostic suggestions.
And because of that transparency thing we were just talking about, the doctors would be able to actually understand the reasoning behind those suggestions, right? So they'd be more likely to trust it.
Precisely. Or what about self-driving cars? Those rely so much on AI already to make these split-second decisions. But with a knowledge implant, you could give them a complete understanding of traffic laws, road conditions, even like predictive models of how pedestrians behave. Could it make them so much safer?
It's like giving them this much deeper understanding of the world,
Yeah.
Because the world is complex and unpredictable.
And that's really what it's all about, giving AI the knowledge and the reasoning skills to deal with all that complexity, but in a way that not only works, but that we as humans can actually understand and get on board with.
This is all super promising. But I'm sure there are still challenges, right? What are some of the hurdles the researchers are still working on?
One of the big ones they talk about is finding better ways to deal with, like loops and conditional statements in the implants code. Like those are basic programming things, but they can really slow the LLM down.
Because it has to go through every single step, even if it seems obvious to us what the answer should be.
Yeah, exactly. It's like, imagine watching a supercomputer try to do basic math, but it's like meticulously counting on its fingers. Gets there eventually, but it could be so much faster.
So finding ways to make those processes more efficient is really key to making these knowledge implants work even better.
Absolutely. The more efficient we make them, the closer we get to this AI that can, reason and solve problems like we do, maybe even better. And that's insanely exciting.
It really is. And it feels like we're just at the beginning of all this. Makes me super optimistic about the future of AI. It's clear the researchers are on the right track, asking the big questions, pushing the limits, and that's how we get real innovation, right? So if you could implant any knowledge directly into an AI, what would it be? And why? Something to think about. That's all the time we have for this deep dive. Thanks for exploring with us. And until next time, keep those brains buzzing.